You got
Go.
it. Okay. Well, now I'm caught off guard, but that's all right. Hi, guys. I'm Jennifer from HVA-Chicks Coalition. Obviously, if you're here, you know who I am. Today's live training is called Callbacks 101. We're going to talk about callbacks and why they happen. What are the different reasons that they happen? What can we do about them? How do we prevent that from happening? And the biggest one, I think, is why do they matter? They're to technicians, sometimes it's not very clear why it matters so much if we have a callback. So I'm going to walk you guys through that as well. Today's live training series, episode 12, is brought to us by Revive Air LLC. Thank you, Revive Air, for your air shield awesomeness. I'm really glad to have just put it in my house. So we'll see how that's going pretty soon here. And we'll have some content coming out this week. So everybody keep an eye out for that. And thank you, Air Shield, for helping us out so that we can train people for free. We love it. Danny, the waiting room, I'm going to turn over to you now. Hey, guys. Welcome, welcome. I am going to turn over the waiting room to Danny now. And if you have anything to add, feel free just to unmute and blurt it out because I do not look at my phone while teaching. So I won't see your hand raised. I won't see any of that. So just blurt it out. No problem. Doesn't bother me at all.
I don't have
So
it.
you don't have what? The waiting room?
Yep.
Well, darn it. You should. You're me. You're me squared, Danny.
Nope.
Okay, well, hopefully I'll let people in if I see them. Whatever. We'll wing it. That's what we do here, right? So, okay. What are callbacks? How many of you have had a callback? Yes, yes, I've had callbacks. I have not had callbacks since being on my own. And that's going to be a great segue into one of the reasons why it happens. But there are lots of reasons. So let's start with the most obvious, the elephant in the room, right? The elephant in the room is technician fault. That is what every callback in the world is blamed on. Immediately, right out the gate, it's a technician fault. I'm here to tell you that that's not necessarily true. Because yes, some callbacks will come from technician fault. Of course they will. Sometimes we move too fast and we miss things. Sometimes we, um, you know, have a sound diagnosis in our head that isn't necessarily a sound diagnosis in the real world. Sometimes we have put way too much stock in manufacturer tech support, right? We call them because they should know their units. They tell us something that absolutely is not true and is completely off the wall. It makes us second guess ourselves as technicians and it makes us change parts that don't need to be changed. Happens all the time. That's still a technician fault because we need to always remember that we are the technician, that we're the ones trained and not necessarily manufacturer tech support and definitely not homeowners or commercial business owners, right? We are the technician. Sometimes we tend to forget that. We tend to get imposter syndrome. We tend to second guess ourselves. And when we do that, we end up with a technician fault that causes a callback. That happens all the time. That's probably, I would say that's the number one reason. And then the number two reason is not a technician fault at all. It's lack of training. So who's responsible for training their technicians? The owner, right? That's who's responsible for that. When you hire a technician, hopefully that technician has been honest about their skill level and their aptitude. Sometimes they're not, and that's because we've been trained to do that, right? We've been trained not to tell the truth on our job applications because we won't get the job. So if we over embellish, we are doing ourselves a disservice, but we have to blame that part of it on a technician fault at that point. If you weren't honest about your aptitude and then you weren't offered training in a certain subject, that's your own fault because you didn't tell them you needed training. Every other situation where you were not offered training in a certain subject is the owner's fault. That's owner fault, period. Your boss needs to provide training, whether he wants to or not, whether he knows how to or not. There is no excuse for an owner not to offer training. So if a technician comes to me, if I say to a technician, you need to go and clean this ice machine, and that technician says, I've never cleaned an ice machine before, and I say, go do it and figure it out, that's going to cause a callback almost every time. And that's because you cannot expect someone, like if somebody told you to go fix a car right now and you're not a mechanic, what are the chances something wrong is going to happen? They're huge, big chances, right? Probably every time, if not close. That is a fault that is not on the technician unless the technician has lied on their application or in passing saying, oh, yeah, I clean ice machines all the time. I'm great at it. And then your boss says, go clean an ice machine. Well, that's why he told you to do that, right? Otherwise, barring that situation from happening, it's an owner fault. So we have now technician faults and owner faults. Owner faults also fall under the category of management faults because some of us work for fleet companies, right? We never see the owner. It's not the owner's fault necessarily. Or it is because he's disconnected from the rest of his business, right? He doesn't understand what's happening with our field technicians because he's so far up the office's ass that he can't see straight, right? So I would also, under that umbrella, put service managers. I would put project managers, right? Anybody that has the ability to tell you to do something without you knowing how and did not offer training. That's going to be our second one. The third one, and people hate when I say this, the third one is homeowner fault, right? Or business owner fault. This is when we get a call back because our diagnosis was sound as a technician. We were given the proper training by our company, but the owner did not understand our explanation. Let me flip that though, because you would say that's technician fault, right? Because we didn't educate our customer. I'm not talking about when that happens. I'm not talking about when you said your unit's fixed by, and now the next day something's happening due to the repair you made and they don't understand that. I'm talking about when you did educate that customer, when you explained to them, hey, I cleaned your burners, but your heat exchanger's plugged. I need a new service, acceptance in order to go clean your heat exchanger. And they say, no, it's running. It's fine. Get out of here. And then the next day it breaks down. That is an owner fault. That is a homeowner or customer fault. Okay. So if I go to a place and I'm there for maintenance, say, and I clean their boiler, it's completely clean. All of the wires are not broken. We've gone through the entire maintenance checklist. Everything is running great. And I tell them it's clean, it's running great, but I can't promise you that this thing isn't going to fail in a day, in a week, in a month, because it needs to be replaced. The only fix for this machine is to be replaced, right? And I know that I, as the technician, have done everything I can to repair and to maintain that equipment, but now it's just at a point where it just has to be replaced. It's no longer safe, right? So when I put it in that situation and I tell the homeowner that, but because it's running, they want me to leave and they don't want me to charge them any more money. They don't ask me for a quote. There's none of that going on. They just say, yeah, it's running, leave. That's going to be a customer fault, right? So if I have a customer fault, there's nothing I, as the technician, could have done other than educate my customer, which I did. And there's nothing my company could have done because they provided me the proper training in order to be able to educate that customer and to diagnose a bad unit that needs to be replaced, right? So all of those are taken care of, but the customer is at fault because they're either not understanding or they don't want to understand. Two of those can be defeated very, very easily. The third cannot. We can educate until we're blue in the face. We can show statistics. We can show specific instances where a boiler blew up or cracked and killed a whole family just this past Christmas Day, right? Just this past Christmas Day, an entire family of 4 of highly educated individuals died in their vacation home in New Hampshire because their technician allowed a unit that needed to be replaced to continue running. That's a technician fault. Now, if that technician had called up that family and said, don't come unless you're going to replace this or use a backup heat, this unit is bad, we can't run it again. In that case, if they still chose to come, that would be their fault. But in that situation, it was not. It was a technician fault. So not only do we need to educate ourselves, we need to be educated by our company, and we need to educate our customer. What is the common theme there? Education, right? That's why we do this. That's why I'm here and not out playing in the delicious snow that I woke up to this morning. Because if we don't educate, we have fear, and fear breaks units all the time. Fear ruins companies all the time. Fear kills homeowners all the time. So we need to make sure that we're combating that with education. So I'm going to show you guys how to do that. Now, I taught an entire class the other day for my fleet company with my phone this direction. The problem is my board is backwards to you if I do that. So I'm going to flip it. Hopefully nobody comes into the waiting room while I do that. And I don't have a flipper. Annie, do I have a flipper? Oh, yeah, I do. Okay. Sometimes I just have to ask Danny things and then answer them myself, you know?
It's just my presence gives you your answers.
Exactly. Your presence is a present. All right. So I think you guys can see most of the board if I leave it like this. I'm not going to turn the gimbal on so that it won't walk on you guys. Nobody's expected to be able to see this board properly. Obviously, you can't. You're on a device. I will post this board in the coalition so that anybody who wants to take a picture can. This board is not a checklist, but this board is able to help you if you're in a situation where you're not sure what to do next. This board will jog your memory really, really well. And anybody who wants checklists on any piece of equipment, please let me know because I have them. I just sent them out to 400 people over the course of the last 3 weeks. You guys are more welcome to them than anybody else. Callbacks 101. So now we know what causes them. So I'm going to break those down in a little bit deeper now. I'm going to go into specific instances where those things caused it. Okay. So, well, let's start with this. Why do we give a shit? Why do we care? Right? We care that we're getting callbacks because the customer is only going to pay once, one time. If the customer did something or if something was out of your control that caused you to have to go back, that's all well and good. The customer will have to pay again. The times that happens compared to the times where it's a training issue or a technician issue are very, very low. So say you put a unit in a house and a natural disaster comes.
What can I get for you today? Can I get 2 of the Coney chili cheese dogs?
Jimmy, mute. Sorry, guys. Okay, so say I put a furnace in a basement.
Large sweet tea, no ice.
Oh my, Jimmy, mute.
Anything else?
Danny, can we mute him?
I can't. You can.
All right. Well, hopefully he'll be done ordering his lunch soon. Okay. So say I put a furnace in a customer's basement. We'll say a boiler just because they're usually in basements. Say it's a floor mount boiler. A natural disaster comes and it floods their basement 4 feet. I just put that unit in 3 weeks ago. Now I've got to rip it out. Yes, it's going to be a warranty call. Yes, there are going to be a multiples of people paying for that. But that's something we can't control. But say you weren't trained on installation and your boss sent you to install something and you did it wrong and something blew up. You let the smoke out, right? You let out the magic smoke. If that happens, the customer is not going to pay for that. Say I actually had this. I had a customer or a tech support caller call one day and say that she was working on a boiler. She was testing the different parts of the board and she dropped her leads. And the leads caused arcing, cooked the board. Customer's not going to pay for that. You are. So that's one reason why it's important. Why is that part of it important? Because any other situation other than barring a natural disaster or a homeowner fault is going to be paid for by your company. One of the companies that I work with right now, 85% of their calls were callbacks, had callbacks. Okay. So 85% of the time when a technician went out and they worked on something, a callback resulted from that. They are now losing 85% of their profit. But wait, they're losing a whole lot more than that because they are losing everything that they pay that technician. They're losing everything they put into that truck that's on the road for a second time, including wear and tear, gas, everything, you name it. They're losing out on other customers that would be taking that time slot. So if I go and clean an ice machine and now tomorrow I've got to go back and clean that ice machine because I missed things. Now, not only are they paying for me to do it again, they can't bill the customer. And they're missing out on having my truck somewhere else making money. So they're not only losing the ability to charge this customer for this call, but they're losing everything they made the first time too. So they may as well have not sent you out, not paid you for the day, not done any of that. Because when you have a callback, it doesn't only negate that job. It doesn't only negate that service call. it negates all the service calls that could have happened during that callback as well. So you're losing thousands of dollars on one callback. So when you have 85% of your service calls resulting in callbacks, you're losing almost double what you made. Think about that. That's a lot of money. That's a money leak. That's a pour, not even a leak. We have to do everything we can to combat that. So using this class and using me teaching their techs every 2 weeks, and them using my tech support line, which is here, and there's a bunch of ways that we can prevent this. Using those ways to prevent it, this company's gone from 85% of their calls to almost zero callbacks on the classes that I teach. And that's because it wasn't necessarily technician fault on purpose. It was technician fault by lack of training, right? Or lack of resources to help you. Even if you are trained, sometimes you still need help. It happens to all of us, right? Well, they didn't have access to that. So that's what caused all of those callbacks. Now they have access to the help that they need when they're on a job. They have access to the why. They're not just going to a unit saying, this thing's low, I'm going to charge it up and leave. Now they know how to find the why of different situations that they didn't know before. So that was not only technician fault because they didn't seek that elsewhere. We have to seek it elsewhere if we're not offered it at work, right? Our ability to be a good technician is not based on where we work. It's based on how much time, how much effort, and how much passion we're willing to put into our career, right? And I'm not saying every waking moment should be HVAC, you guys, because it shouldn't. Absolutely. I have a hard time with this myself. What I'm saying is when I started out, I would have been 100% callback tech if I hadn't looked for resources on my own. If I had not put myself out there and said, I need help. Who can I watch? Who can I listen to? Who can I ask, right? You have to build a community of networking peers, but we've already done that for you. So if you're in the HVA-Chicks coalition, no excuse for callbacks. You have to use your resources that are allotted to you, and we will talk about that. But first, let's only solely jump into technician fault and lack of training, okay? So these are the things we see specifically in units that cause callbacks the most. And you guys feel free to yell stuff out if you need to, questions, whatever. And then after I'll bring you guys in even more to talk about ones that you've had. So the most common ones are on maintenance. Always. Maintenance is the most common callback. There's lots of reasons for that. First of all, technicians that don't know any better, that do know better and don't do better, or technicians that miss things because they are overthinking, they're not reading the manual, or they're moving too fast, trying to get 10 calls done in a day, right? And that's what everybody's boss expects out of them. This is where the catch-22 comes in. Your boss wants you to run 10 calls in a day. To do 3 quality calls in a day is all you have time for. So do we take the quantity part out or do we take the quality part out? Every technician's faced with that every single day, and it sucks. But I'm here to tell you that if your company is asking you to bypass quality for quantity, you need to be looking for another job because they will see you the same way. If they see every job as a dollar sign, they're going to see every technician that same way as well. So you don't want to be there. All right. So the first most common on maintenance that's missed is airflow. Dirtiness. Most of the time we show up at a maintenance call and go, I'm here to clean this unit, right? So most of the time we do clean it. Sometimes we don't. Sometimes we look at the coil and go, it looks fine. And then we walk away. And then now that everything else is working properly because we just did maintenance on it, now that airflow is showing its ugly head, right? We've got frozen suction lines. We're getting callbacks for no cooling the next day. Huge problem. So don't just look at a coil and go, it's clean. Okay, so we have a couple of situations where it is not clean. The first is it's not clean on the inside, right? The second is it's a stacked coil. So you may have looked inside and outside, but all you're seeing is the front surface area and the back surface area of 2 separate coils. So in between those 2 sandwich coils, you have a fur coat, which is not going to let any airflow pass through from the inside to the outside or for the outside to the inside. So you need to make sure that you are inspecting every coil. It shouldn't just be, I'm here for cleaning. You're not here for cleaning. You're here for a preventative maintenance visit. That comes with inspection, and then it comes with reversal or repair, and it comes with cleaning. Just one part of it. So as soon as you show up on a maintenance, if you're not cleaning the coil, you better tell me it was put in a week ago, because that's the only reason not to clean a coil. Electrical, right? And we're going to go more into this on service, more into the airflow, but that's the number one thing that's missed on maintenance is a dirty coil, right? As far as airflow goes. Electrical. Oh, and let me actually add to this. If you're on a furnace, if it's a 90% or plus furnace, you have a secondary heat exchanger. The amount of technicians that even know that, let alone look for it or look at it, very, very low. If you're on a 90 plus furnace and it has a secondary heat exchanger, your head needs to be up behind that blower looking at it, because probably 9 times out of 10, when I get a call for high limits tripping on a 90 plus furnace, etc., overheating of any kind, it's because of that secondary heat exchanger. You need to have eyes on it. And the reason that it is so common that that's the breakdown is because it's missed on maintenance. People either don't know it's there, they've only worked on 80s their whole life, they have no idea that that's there, or they don't want to pull the blower in order to get a good look at it. And they know that if they pull the blower and look at it, it's going to be dirty, so they have to clean it. They don't want to. So a lot of people will skip over that entire part of preventative maintenance. Don't be one of those technicians. Electrical. Usually it's start run components, right? You guys have seen this a million times. Sometimes it's an overamping fan. So I lost $50,000 worth of frozen food in an icebox freezer because I didn't amp the fans. So I cleaned the unit and the unit was running a lot better and it was passing more airflow, and the fan junked out because it was overamping the whole time. I missed it. I lost $50,000 worth of food for my customer, and my boss at the time we never came back from it. Let's put it that way. That is a callback you don't want. Okay. Amp your fans. If you are at any type of maintenance for any piece of equipment, put your amp clamp around your fan wire and make sure it's not locked rotor. Make sure it's not super high resistance. You can run it in resistance as well. You can do amps or resistance. It's not going to matter. It's going to tell you the exact same thing. And make sure you're writing it down, you guys. That's the other thing. On maintenance, I ask my helpers that I have to do maintenance. I don't have any other techs other than Val and I, but we all write down our numbers. So if I amp a fan, that number is going next to it on my service sheet. If it's on my service sheet or in my CRM, then the next time I come and I watch that amp number climb and I say, well, when I was here 3 months ago, this ice machine fan was X amount of amps. And then I came back 3 months later and it was a little bit more X amount of amps. Now I see a trend happening. Now I know that it's overamping either because it's dirty, filthy, there's something else blocking the airflow, or it's going bad and I need to change it before preventative, right? To prevent my customer from going through a breakdown. Shorts and stats. Happens all the time, especially in the residential world. We see nests, right? We see nest stats that have a real problem with grabbing voltage through the back plate, shorting itself out and chattering the contactor. We see this all the time. It's not just nest by any means, but those have a real problem for the back plate issue. There's also a series of Honeywell T6 that has the same problem, not quite as severe, not quite as often, but like 1 out of every maybe 12 from the supply house, you'll get that problem. Shorts are because of rub outs and pinches for the most part. If you're on maintenance and you have not put eyes on every wire in your system, you're doing your customer a disservice and yourself. You're not teaching yourself anything. So I may look at the start run components, look at the wires that go to my start run components and go, everything's fine. Maybe those wires are covered in dust, right? Or maybe there's a critter in there that I noticed a nest, but I didn't see the critter, so I didn't think anything of it, right? Really, there was a teeny tiny break in that wire. That would be very, very hard to spot unless you were looking for it. So if I'm not looking for it, I'm not going to spot it, right? So when that critter comes back home looking for his nest and it's now gone and he goes haywire and he starts chewing on wires, well, this one, say our capacitor wire was already broken, going to be immediate shutdown. It's not just that though, pinches. You're at an RTU, right? And you pull off the panel. And then when you put back on the panel, some of those wires were kind of sticking out. So you shove the panel back on, it squeezes those wires together. That can cause arcing. B, it can cause pinching, which will eventually end up in a rub out or a break in the wire, right? We need to make sure that we have right here tape and ties. Tape and ties are your best friend. Make sure you have a roll of electrical tape and a package of zip ties. Every single unit you walk up to on maintenance. You are going to have to string up wires. There was somebody else here at some point repairing something. He cut the zip tie and he left those wires hanging. Every single time you're going to see it. Or just from the factory, they don't have a real good method for hanging their wires, maybe. You want to be the one that prevents that, that makes sure that this unit is impossible after I left here to have a break in the wire or a rub out or a pinch, right? So you want to be the one that taped up everything that looked questionable. Sometimes you'll have a sunspot on a wire where that wire was exposed to the sun for whatever amount of time, and you want to just put some extra tape around that. Totally fine. Say you have a piece of the wire insulation missing, but it's not broken all the way through. Don't just think that's not a rub out. I'm going to be fine, because if ever a rub out's going to happen, it's going to be on that wire. Wrap some tape around it. It takes you 2 seconds, takes very, very little material, and your customer's paying for you to do it. So just do it. Hanging your wires matters too, especially in RTUs, you guys. If you see just a mess of wires, wrap a zip tie around it. Hang it to somewhere. It's so fast, so cheap, and will make the biggest difference of your life. You should always be leaving a unit better looking and better running than when you got there. If you didn't, then you didn't do your job as a technician. Leaks. We miss oil all the time. We much less often miss water. But if you have a coil that you didn't inspect, you saw that it was dirty, you didn't inspect that coil, you remove the top, you go inside out like you should as a technician to clean that coil with your water hose, and now the entire coil is covered in water, so it all looks wet, right? And then you go home. What you missed was a massive oil leak on the coil because you didn't look. So after you cleaned the coil with a brush, you didn't inspect it while it was dirty, first of all, but you also didn't clean it with a brush before you hit it with water. So now you missed any oil spot that might have been there, and it may have been big enough that your unit is almost flat, or that it's holding just under the pressure limit, right? So it's not shutting off, it's running. You think everything's fine, no reason to gauge up, right? We don't gauge up on every maintenance, not even close. So if you don't gauge up, you're not going to notice that it's low unless you see evidence of that, an oil leak. So anytime you walk up to a unit especially an AC unit, same really goes for refrigeration, except that some coils are different in refrigeration. But anytime you walk up to one, you want to inspect the coil. Is it dirty? Yes. How dirty is it and what's on it? Because sometimes you'll have concrete on it. You don't want to hit that with water, right? If somebody just had some renovations done, this happened to us at our lobster place. Our brand new units got absolutely filled and plugged with concrete dust because nobody wrapped them or had us come and protect them. After that, I got there to clean it and went to hook up my hose and I can't put water on these coils, right? So I had to sit there with a brush and brush all the concrete dust out of it best I could. But if you do that, if you didn't look, if you just said this coil's dirty, you don't know what that contains, you don't know what's in it, and you're going to miss oil spots, period. So always inspect before you do anything, because if you miss an oil spot, that could be your call back tomorrow for low charge, and nobody wants that right after a maintenance. These are the big ones, though. I would say rarely we miss an undercharge, unless it's a situation where we miss the leak. Rarely we miss an undercharge. Often we miss an overcharge. So probably 8 out of 10 technicians that I interact with anyway, their first thought and the first thing they were trained on is to spot a charge issue that isn't there. A made-up charge issue or the wrong charge issue, right? So rarely do we look at airflow. Everybody forgets their ABCs, right? Airflow before charge. So they go immediately to charge. They have let's say it's a heat pump mini split and it's winter and we have a no heat call. The first thing they do is jack a little bit of refrigerant into there, assuming it's low. No reason to think that. Your gauges will not tell you that on a mini split. It's an inverter compressor. We've had this in our mini split class. If you guys haven't watched that and want to know what I'm talking about, go back and watch that. But we know that we're not seeing an undercharge in our mini split with our gauges in the winter, especially. So why? Why did they jack refrigerant into it? Simply because they were told by their old head, beer can cold, jack refrigerant in until the suction line's cold, or they assumed. They made a absolutely uneducated assumption. Okay. That happens all the time. So then now it's winter and I'm getting 60-degree air out of my supply, out of my indoor head unit. Why? Because when that technician jacked refrigerant in the winter, now it's summer, our superheat's going the other way, our subcool's going the other way. We've reversed, right? We have right here a heat pump. We have reversed the cycle. And now it's showing its overcharge. Now it's rearing its ugly face because now we have a too cold of an outdoor coil, not able to reject heat because of overcharge. Or we have not cold enough of an indoor coil. We've got a 57-degree vapor saturation because it's full of liquid refrigerant, where it's not supposed to see it, right? Or even worse, we have a down compressor because it's been trying to compress liquid. Compressors are not pumps. They can't compress liquid. They can only compress air, right? So if we have now in a mini split, we have I have it somewhere here. Oh, right here. I don't know if you guys can see it, but we have in a mini split, we have a accumulator. Now it's not the same as an accumulator in, say, a refrigeration unit. I mean, it does the same thing. I guess it is kind of the same, but that accumulator is the entrance to it is right next to the compressor. There's nothing stopping that thing from overfilling and putting too much into the compressor. It's going to do the same thing. It's not built as a reservoir, right? It's an accumulator. It's not a reservoir that's meant to hold excess refrigerant. It will hold excess refrigerant, but that's because of how the system is running naturally, not because we jacked a bunch of refrigerant into it. It's not built for that. It can't do it. So instead, we end up with an overcharge, which kills our compressor eventually. The next reason is because restrictions lie, right? Most techs were never trained on how to spot a restriction. They were taught how to spot an undercharge. So when you think every restriction is an undercharge because your evaporator's empty, so say you have your evaporator, it's got X amount of, how should we do this? We've got 17-degree vapor saturation in our evaporator. But what we didn't do, and so that makes us think it's low, right? But what we didn't do was look at the condenser side of our gauges. Okay. So if the condenser side of our gauges is showing too much liquid refrigerant and the evaporator is empty, that tells us that we have a restriction. The system isn't missing the refrigerant, only the evaporator is. So that means that either our TXV or something else on the liquid side has cut flow to the evaporator. Happens all the time. We miss it because all we look at is the evaporator side. We look at our suction line temp and we look at our evaporator temp and we look at our supply air, right? So that tells us we don't have enough cooling because it's low. We jack more refrigerant into it. Well, no matter how much refrigerant you jack into it, it's not going to make it past that restriction. So all of that excess refrigerant has to go somewhere. It floods the outdoor coil. And if you put too much in, even after that, it's going to flood your compressor. End of story. It can't make it to the evaporator unless you deal with the restriction, no matter how much refrigerant you put in. So that happens all the time too. Tech goes up, sees a low evaporator, adds some refrigerant. It didn't really work, but maybe my indoor air dropped by 3 degrees. So I assume it's going to keep dropping and I'm just not going to sit here and wait. Well, that doesn't happen. You have a callback the next day because now everything's flooded and maybe your compressor's out, right? Those are the most common on maintenance, but they're also the most common on service. I will say that. So I kind of did the exact same thing. But there are more on service that are easier to miss because when we're on a service call, our mindset is different, right? It's harder to miss it on maintenance when your whole job of being there is to prevent bad things from happening. And when people think in their minds of maintenance as a cleaning visit, that's all they do. They only clean it and then they leave. When you're in that thought process, A, it's really, really easy to get callbacks. But B, you need to change it anyway because that's not your job. You're not even thinking of your actual job. Your actual job is only to prevent bad things from happening. Cleaning is a part of that because cleaning dirtiness causes breakdowns, but it's only a part of it. So again, if you need checklists, reach out. No excuse to miss things on maintenance. But in service, your mind is, I'm here to diagnose. I'm here to find out why all this shit is happening. Why isn't my customer cooling? What can I do to help them? So when that happens, we think, A, we were not trained properly, and we think everything is a charge issue, right? A lot of people show up to a unit and immediately think it's the charge, just like why these two things happen. So I showed up and I thought it was a charge issue, but really what happened is I missed my drain backing up. Never a good thing, right? I just jacked more refrigerant into it, causing an overcharge, or I jacked more refrigerant into a restriction, causing an overcharge, and a slugged compressor. But I didn't deal with the fact that there was water coming up out of my drain and nothing was cutting the call because the float switch was not put in properly.
Jen, turn
Right?
your camera a little bit.
What?
Turn your camera the other way a little bit. You can't see that side.
That way?
And check your waiting room. Yes.
Oh, shit. Good plan. Yep, we got people in the waiting room. Sorry, guys, I didn't see you in the waiting room. All right, hold on. Let me put you guys back. Do. I don't know how. Okay.
There you go. You also have
Better?
two questions in the chat.
Oh, guys, just yell them out because I'll never see them.
I can read them to you if you want. So one question Rudy asked was, how long should a maintenance take?
That depends on the equipment. It depends on the cycle. So I'm going to use boilers as well. You're Rudy and you're in sunny California, so I won't use boilers as an example. I will say like a typical residential maintenance, okay, for a conventional split heat pump. If you're there every 3 months and it's a commercial situation, you're going to have a whole lot less time on your maintenance, right? If you're there biannually and it's only twice a year, spring and fall, you're going to have a little bit more time than that. But if you're only there annually and they only clean that thing once a year, you're going to be there a whole lot more time. It also depends on, I would say, per piece of equipment, it should not take less than an hour, I would say, unless it's quarterly and you show up and everything you just did is exactly as it was last time. But you still need to verify that, right? You're still amping fans. You're still taking electrical readings. It's still going to take you some time. But I would say I would not want, if I had a tech that I sent to a maintenance visit, I would not want to hear from him until an hour later saying that he was done and moving on to the next piece of equipment. That wouldn't, I wouldn't think anybody could do a quality service in that amount of time. But that being said, there will be situations where that's not the case. If it's a little reach in and you were just there 3 months ago, it's going to take you 10, 20 minutes. So it depends on the equipment, I will say. But I will say this, your best friend in that situation is a checklist, because if you completed your checklist, it doesn't matter how long you took. That's a quality maintenance PM, right? So that's going to be my advice. What was the other question, Danny?
Your other question is from Jason. He said, what about washing a coil in 45-degree weather? Coil is cold because of water and ambient is low, so efficiency test never passes.
Yeah, we don't want to do that. I don't do that personally unless it's absolutely necessary. If I show up, say it's a new contract, it's not one of my maintenance contracts, and I show up and they're not, I mean, depending, I do a lot of weed houses, so they could be cooling in the winter. But let's, for heating and heat pump mode, we'll talk about that first. So if I were to show up in 40-something degree weather and the coil needs to be cleaned, I'm going to make sure that coil needs to be cleaned. And that's why I'm not heating. It's just something you want to avoid. If you have to do it, you have to do it. At that point, you can use like a leaf blower, like Nick has a leaf blower. I would probably use that to blow off the coil as best I could after. But I definitely wouldn't want to leave it wet and running in 40-something degree weather at all. That's absolutely true. And not only that, but you should never, ever test it directly after while you have a wet coil. I don't care if it's 70 degrees out. If your coil is wet, you're not going to get the correct readings because that water is now acting like a refrigerant. It's cooling. You're pulling. So your lines, right, are now pulling the heat out of that water and not just the air. So we want to always make sure that our coil is remotely dry by the time we're taking any readings that are going to matter at all. Okay. So other things that we miss drain and condensate all the time. Plug drained or condensate pump that isn't running, or maybe it's not pitched right, things like that. We miss that all the time. That should be, after cleaning, that should be your first thing that you're doing. Really, honestly, like I wouldn't want you to do that at the end. You don't want to find a clogged drain at the end and go, oh, this is why I'm here for a service call. And I just did 85,000 other things. Check your drains. Check them first or check them second, period. It's very, very common that's why we're there for a service call. Short cycling. This is one that goes missed so often. I can't even begin. And that's because we're not timing it, right? We might be, so I have a lobster place where I have a bunch of condensers outside, right? So if I'm there for maintenance and I'm cleaning a condenser coil because I just got a whole bunch of concrete dust in it, right? So I'm sitting there for 3 hours cleaning one coil. So I'm there and I notice that the unit behind me is short cycling. And so then I'm like, okay, I'm going to finish this coil and I'm going to go investigate that. And then I can't find a reason for it to be short cycling. The indoor air, the set point is far enough away from the load. So it's not a short load. It's not, something else causing it that I think is an immediate harmful problem. So then I'm going to check the nameplate and I'm going to go, oh, it's 3 tons oversized. That's why it's short cycling. So do we not say anything about that because that unit's been here and it's been doing its job for 5 years? If I'm there on maintenance? No, we're preventing, right? We're giving them options. We're giving them the correct information about their unit so that they have that information, that education for years to come. So if I notice a unit short cycling and I find that it's because it's oversized, what's going to happen? What's happening inside? What's happening inside when I have an oversized unit short cycling is no dehumidification. A unit has to be running to dehumidify. So the reason we run manual J, the reason we size units properly, and we're sizing them small now in the world of tight homes, right? So the reason we do that is because we need that unit to run as often as possible. We want heat pumps to run constantly, 24 hours a day, if they can, as long as they're not undersized. So they're running 24 hours a day and just jacking light bills up and not actually keeping us comfortable. But we want them to run as much as possible. So if it's short cycling, it's reaching set point. So say it's 65 in the house, it reaches set point at 70 in 3 minutes and it shuts off. I've not had enough runtime to dehumidify. So now I have a temperature that is 70 and a humidity rate of 85. So now my surfaces are sweating. I feel disgusting and sticky, but cold, which is super weird. To feel humid and cold is a very weird thing, but it happens all the time. So if I find a unit short cycling, I'm going to check and find out if it's an electrical issue, if it's an airflow issue, what kind of issue it is. And if it's none of those and it's a sizing issue, I'm going to write that down on my maintenance sheet. And I'm going to say, Mrs. Jones, your unit, we didn't know what we know now back when you had your unit installed. And somebody installed a unit that's too big. So no, we don't need to rip it out right now, especially if you're comfortable. There are things that we can do to create dehumidification outside the unit. We can add, like a Santa Fe Compact 70 or a ducted unit. But it's something you need to think about because not only is it not keeping up in your home, but it's also breaking your compressor. It's not good for wear and tear on our unit when it short cycles its whole life. So this unit probably isn't going to last the way your last R22 one did that was properly sized. This one's going to last maybe a year or two more, and it's going to be time to upgrade. Well, downgrade in this situation, right? So always take note of things like that. Is the unit short cycling? Very easy thing to spot, but only if you're looking for it. If you never, ever, ever go and watch the runtime of that unit, you're not going to find something like that. And something like that is so valuable on maintenance, I can't even begin. But when is it more valuable? Is when you just had another company do maintenance on that unit. They didn't say anything about that. And you showed up for a service call that was just a clogged drain, but you noticed that that unit behind you was short cycling. And you were able to warn Mrs. Jones about that so that she doesn't call that same company for maintenance. Now she calls your company for maintenance. She calls your company for service, and she calls your company when it's time to replace it because you just added that much value onto your ability as a technician and your company's ability to hire technicians, right? Miss Jones is going to love you. Missed maintenance opportunities are the #1 reason for breakdowns, for service calls. So if you are on a service call, it's a unit that hasn't had maintenance and you get it running and the next day it goes back down again because you never changed that filter that's been there for 4 years. So you had it out, it was running, you cleaned the coils, you took your temps, you put the filter back in and you left, you went home. Well, now it's choked out the unit again. So now you're back for a callback. Now everything you did yesterday is negated, does not matter. Because now you have not made any money, but you've lost money for your company on that callback. And you've lost money for your company on both of those calls. Because if you had done your job when you were there before and you didn't have a callback, we'd have made money. But now because you didn't, that whole first visit is negated. Doesn't matter. We didn't make $1. And not only that, but you are costing me money by being there again because you're not somewhere else making money. Make sense? Leaks in water and reefer happens all the time. Boilers, maybe it's running. You have it running at its max capacity because you're doing testing and maintenance and you don't see any leaks. Everything looks good. You leave the next day. It's maybe warmer outside. So that boiler is off for longer. And now you notice a pump that's seeping, or your customer notices a pump that's seeping. They're going to call you and say, preventative maintenance, isn't that preventing things like this from happening? Right? If you had cooled that boiler down, taken that time, that extra few minutes to cool that boiler down, and then watch it while it's cool, watch all of your connections and all of your valves while it's cool, you wouldn't have missed that. That would have added so much value to that maintenance because it wasn't a service call. And when you do that on maintenance and then the next day you get a service call, your company is not being paid, period. Shorts, again, shorts are misdiagnosed all the time, or they're diagnosed, but the person that diagnosed it doesn't know how to find it. So here's a trick. If you've gone through, you've checked all your safeties, none of them are melted, you've ohmed them out, you know what their resistance levels are, and they should be good. Okay, and you've done the same, you've tested your thermostat, you know it's not the thermostat. You've tested the board, voltage in, voltage out. Because if you have voltage into a board and no voltage out, the board's bad. You can't get past that, right? You can't not send voltage. So, I mean, there's situations where the short is in the board, but it's not every time. And boards are misdiagnosed all the time as shorts, okay? If you have checked all of the components that can cause shorts, and none of them have done that, and you know your incoming voltage to L1, and you know you have your neutrals, you have your grounds on correctly. If you've done all of that and you're still not sure where the short is, pull off your wires. So if you have a wire, which of course I don't have here right now, if you have a wire that is disconnected on both ends and you read that wire for resistance, you're going to get OL, open line, right? So now you have a wire that's broken in the middle and is touching something. And you read that wire, it's not going to read OL. It's going to read either infinite resistance or resistance of some sort. So any wire, if you're testing it for resistance, you should get OL. If you don't get OL, you have a short, right? So say you have a thermostat. The thermostat's good. You've tested it. You know that. All the safeties in the system are good. But you keep getting a weird short from the thermostat. And those wires are in the wall. So you're not putting eyes on them. You can't check for breaks, right? Or rub outs. Or chewings from critters, which is typically what it is. So now you've got to unplug your R wire, test it for resistance. If you get anything but OL, you have a short on it, right? It's a really, really, really simpler way than ripping out the sheetrock or just running a whole new thermostat wire just because. It's a way that we can have a sound diagnosis without having to be destructive to find it, right? So that's just a little tip and trick, but shorts are misdiagnosed all the time as board issues. A lot of the time you'll see like a flame rollout shorted. Now the flame rollout is cutting voltage to the gas valve, but now you've replaced the gas valve because you thought the gas valve wasn't taking voltage somehow, right? Or whatever it might be. You just didn't understand how that worked. And so now you are replacing stuff that has not shorted at all because you didn't know. You have to understand the sequence of operations to find a short. And if you don't understand that, make sure you go watch one of our videos on it. We have lots. But yeah, shorts are very hard to find to begin with. So not being able to find them is one thing. Not asking for help is another thing, right? If you have a short that you've been chasing for 3 hours, you have a tech support line that's free 24 hours a day that you can call and we'll help you. Make sure you use that. And we're going to talk about that too. Airflow misdiagnosis. I go to a house. I have high head. and low evaporator temp. Oh, my coil's dirty. I clean my coils. I get better supply air by a little bit, and then I leave. Well, I've just misdiagnosed a restriction because my evaporator was empty and my condenser was full, but I didn't know that because I saw a dirty coil. So now all I'm looking at is my high head pressure. Well, that's directly correlated with my dirty coil. So, okay, now I know what to do. I unhook my gauges. I go, I clean my coil. I get 3 degrees less on my supply air now. I'm out of here. Really, what happened was an airflow misdiagnosis. The problem wasn't airflow at all. It was restriction. This happens all the time. Always airflow before charge because you can discount your airflow much easier than you can discount your charge. So make sure that it's not an airflow problem before you check to see if it's a charge problem every single time. That will cut callbacks in half. The other thing that will cut callbacks, so let's get into prevention. Number one thing is education. Know how to read your gauges. If you're going to gauge up, you better not be gauging up unless you know how to read those gauges. You know what correlates to suction temperature. You know what correlates to evaporator temperature or vapor saturation. Same thing with liquid saturation, condensing temperature. You know what a coil has to look like on gauges in order to be removing heat and blowing it to the outside. You also know what the evaporator has to do in order to create superheat, right? So we have to know what all of those things mean, first of all, and then we have to know what all of those components do. And then we have to be able to look at our gauges as two sides of a system. And I can't get those off right now, but I'll show you what I mean after. If I look at this side as my evaporator, this side as my condenser, and I never, ever, ever only look at one, then I'm going to cut callbacks in half on charge issues. Because now I know I'm either looking at missing refrigerant from the whole system or missing refrigerant from one side of the system. And that is going to depend on whether I'm low or if I have a restriction. And if I don't do that, I'm going to have a whole lot of overcharge callbacks. So make sure that you are knowing your gauges. If you need more help to learn them, if you want to take one of our classes to learn them, please do. Like, no excuse for not knowing how to read your gauges either. RTFM, obviously, right? Read the manual. I don't care if you have a checklist for every piece of equipment that Jen Manzo sent you. Read the manual, because sometimes there's pieces on maintenance or on service that are solely correlated to that brand. And that brand needs you to do those things. Happens all the time, especially now that we're getting into A2Ls. We're gonna have a whole bunch of different refrigerant leak detectors, right? RLDs that are put in these units. We need to know how those RLDs work because we were not trained in that. Absolutely not. We didn't have A2Ls when we were learning. So we need to know how they work, and we need to know what everything means when it comes to those. If they failed, if they didn't fail, if they're doing their job, we need to know what that looks like. And it's something we don't know now. So make sure you read the manual. Tape and ties, we talked about. Always tape, always ties. Clean it up. I don't care if you messed it up or not. If you show up on a maintenance or a service and you've got wires hanging, they better be taped or zip tied up after. Because if not, now you touched it, now it's your problem. Slow down. Slow down, guys. We work way too fast. This is not something that can be taught. And it's not something that is solely to you. It's to every single technician out there. We're told to hurry up and wait all the time. How many times have you had your boss tell you to hurry your vacuum up, right? Maybe it was before big blue hoses. Maybe it was when we were still pulling through manifolds. And your boss is like, why is your evacuation taking 3 hours? And you're like, I can't speed it up, bro. Just sitting here waiting. So you have to hurry up and wait a lot. The other thing that we have to do is focus on one wire, on one component, on one piece of equipment at a time. I once met a technician who on a roof of 100 RTUs, say, it was probably closer to 10, but even if it was 100, he would have done it the same way. 100 RTUs, okay, on this roof. And this technician goes around and changes all the filters. He goes back around and changes all the belts. He comes back around and checks all the coils. If they're dirty, he cleans all the coils. When he's doing that, and he's going unit to unit to unit to unit to unit, he's probably missing a lot of things, right? He's not dedicating any moment of pure focus to any one of those units. He's looking at it as a whole. When you look at it as a whole, you look at your checklist items. You look at coils, pinches, blah, 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 in a row. But you look at it for 100 units, not one. You need to be able to dial yourself back in, slow down, and focus on one piece of equipment at a time. And even more so than that, focus on one task at a time. And even more so than that, focus on one component at a time, one safety at a time. If you are taking readings and you're putting them down, you're not going to miss anything that way. You will know I'm not leaving this unit until I know for a fact every single item is checked off and that this unit is running properly. That's the biggest advice I can give you. Never try to tackle a bunch of projects at once, ever. SkillCat. Those of you who are on SkillCat, message me. You should be on SkillCat. It's $9 a month. We have scholarships, so there's no excuse for anybody to not be on SkillCat. This is the online trade school that I am the chief trainer for. We do a whole lot of community stuff, but we do even more for our individuals. I can assign whole training plans. I can get you licensed if you're not licensed. I can do so many things with the use of SkillCat right on your phone in your own time. You can dedicate 5 minutes of your day and you can learn an entire concept. You can dedicate 30 minutes a day, a couple of days a week, and get your whole ass EPA license or all of your NATEs or whatever it might be. You can take the new Brian Orr courses that we have on SkillCat. You can take the new HVAC know-it-all. Like, I have brought every single good trainer in the world into this app. And now we all work together. If you want a comprehensive school that doesn't cost you $6,000, that doesn't take all of your time, that you don't have to go to after work for 3 hours a night, get on SkillCat. And if you're not on SkillCat, do not sign up without my discount code. It's HVA-Chicks at checkout, but I can also send you a link that will help you kind of get there a little more easily. Tech support line, 24/7, free. No reason not to use it. And this is what I tell I teach whole companies for SkillCat as well. And this is what I tell my trainees in those companies. If it has taken you more than 1 hour to diagnose a problem on a service call, you need help, period. I don't care what the unit is. I don't care if it's a massive industrial Hearst boiler. If it's taken you more than an hour to at least get in the correct area of diagnosis, you need help. So now I know I need help. What do I do about it? I call tech support. If you're one of those people that hates to call tech support, that hates to call anybody, you can go on the HVAC Know-It-All app and you can post there. Our tech support line partnered with HVAC Know-It-All, so you can literally make the post online and get all your answers that way, or you can call us, or both. We are there 24/7. Jimmy is in here. He's one of them. Let me see if we have anybody in the waiting room. Sweet, we don't. Jimmy's one of the people on there. Ryan is another one, my co-host for Misfits of HVAC. Val is another one, and Maddie, HVAC Grammarian. We have specialists in all equipment. We have, Carlin, we have Aon, we have Carrier, we have every single equipment you could think of. So there's no reason not to call. If you choose not to call, you're choosing not to diagnose soundly, you're choosing that to be a technician fault, and you're choosing that callback. The only thing we can do to prevent callbacks is not choose them, right? So if you're doing all of these things right, but you can't figure out what that diagnosis is soundly, so you guess, you're going to get a callback. That's going to negate everything you just did. It's going to look really, really bad on your record. It's going to look really, really bad for your company. And your customer is not going to trust you anymore. We can't prevent all callbacks. And that was the point of me telling you that there are 3 reasons for them. We can prevent all of our personal technician fault callbacks. YouTube University. I went here before I went anywhere else. Actually, I think I went to SkillCat before I found the YouTube world. YouTube is a great way to learn. First of all, I would never tell somebody to take all their learning from there, but I can't tell you how many times my jerk of a boss wouldn't teach me something because he didn't know either. And instead of just saying, I don't know, and bringing somebody in to teach me, he said, figure it out on your own, or you're in big trouble, right? When those moments happened to me, I was immediately on acservicetech.com, or I was on YouTube, or I was on hvacknowitall.com, or I was on hvacschool.com. And I was searching and trying to find the answer. And they never let me down. So if you need something on site, or maybe something happened that was super fucking weird, and you're like, I don't know what just happened. I've never seen this before. And you go home and you're still thinking about it. YouTube's a great way to find out what happened and to get it off your brain so you can spend time with your family. WhatsApp, you guys don't have, but we have a Discord for you guys. We'll probably have a WhatsApp eventually, but Discord for you guys. If you need help, you're not sure of something, you can message the Discord. You can message the HVA-Chicks message thread. You can message the book club thread. I don't care. You can message me directly. But call the tech support line if you're on site with a unit, because that is the best way we can help you. Not only do we tell you what we think is wrong, we're not like manufacturer tech support. We're not reading, a flow chart. We're actual technicians who have actually seen it or who actually know how to find our way to that sound diagnosis. So when you call me or Jimmy on the tech support line, we're not going to say you need to change your XYZ and then hang up. We're going to say, give me all of your readings. If you don't know how to make those readings, we'll teach you how to make those readings right here while we're on the phone with you. Then we'll teach you what those readings mean, how that correlates to actual equipment. And then on top of that, we'll tell you exactly where we need to start. And we'll sit there on the phone with you while you start, while you make your way through, and then while you finish. And then at the end of it, you'll go, hey, I just diagnosed that unit. And we'll say, yeah, you did. And then you are the star of the show at work. So make sure you utilize that tech support line. This is exactly what cut callbacks from 85% to barely any at the company that I work for. Graphics is another good one. JD Kelly, our sponsor, makes a lot of those for HVAC school. They're effing amazing. If you're a visual person and you don't want to have to call the tech support line, but you're really, really good when you have something that you can revert back to and go, oh, okay, I missed this. Okay, this was my superheat, so this. Those graphics that show like up, down arrows next to like, what does an airflow issue look like? It'll be like down for suction, up for head pressure, like whatever. Download one of those, keep it on your phone. Go check out JD's graphics, keep them on your phone. Very, very good for visual learners. And then the last but not least, if you're not testing, you're guessing. I don't want to hear your airflow was good when you left. I don't want to hear your fan wasn't bad when you left. I don't want to hear my compressor was running when I left. I want to know the outcome of your CSR test on your compressor. I want to know what your decibels were. Was your compressor loud or not? I want to know how much airflow were you getting before with your coil dirty and how much airflow are you getting now that that helped. I want to know what your supply temp is. I want to know your TESP. I want to know your friction rate. If you're not testing, you're guessing. So you can say, my suction line's frozen, my charge is good, but I don't think it's a return clog. I don't want to hear that. I want to hear, I know it's not a return clog because I took the measurement and I checked to make sure all my return registers were soaring, air back to my unit. I don't want to hear good. I don't want to hear running. I don't want to hear any of those things. I want to hear what was your measurement. And if you know what your measurement was, you can prove that to the customer. You can prove that to your boss. Say you call and you say, I have a bad board to your boss. And he says, I don't believe you. We just put that unit in 3 months ago. Or we just changed that board, right, Rudy? We just changed that board. You need measurements to prove that. And once you prove it, nobody can argue with you about it. Nobody can say, I'm going to send another tech out there. Nobody can say to your company, send somebody else, I don't trust him. Why? Because you just proved it. Use MeasureQuick. MeasureQuick is another great one that I forgot to put up here. MeasureQuick will not only test your whole system with you, but it will tell you what to look. It'll say, this is the problem, look for this, right? We're about to be tech support for MeasureQuick as well. So it'll be a big community of awesome help all in one place. Use it. If you don't use your resources, then you can't expect not to have callbacks. Callbacks are the bane of HVAC existence, but they happen for a lot of reasons. And sometimes we can't blame ourselves, and sometimes we just have to. All right, guys, I'm going to turn you around now for discussion. Anybody have, Danny, do we have any more questions in the comment?
Let me take a look. I was taking care of something.
No worries.
No.
All right. Anybody have anything to add to this? A callback specifically that you had, something like that you want to add to teach other people who will watch this in the future? All right. Any questions about anything I said? I know I don't like to ask you guys
one thing.
questions. Oh, go ahead.
If you're not sure when you're doing something like that, please, when in doubt, stop, back up, take the blinders off, and look at the whole picture.
Yes, take a break. Take a break. Taking breaks is so important. Sometimes you'll get tunnel vision and you're like, I know my short's here, right? Really, you're on the other side of the equipment as to where the short is. It's because you've been working on it for so long, your brain's tricking you into, we've now invested so much time in this, we have to find it now, and we have to find it here, or it's not worth it. Walk away, reset your brain, come back, look at the whole picture. Okay, these are all of my symptoms. What do all of these symptoms cause, right? Not just one symptom. That's a really good one, Jimmy. Very, very good. All right, guys, we have book club tomorrow at 2. For those of you who are in book club, if you're not in book club and you want to be in book club, come join. It's not too late at all. We can always add more members. And it's like literally the most awesome book club I've ever been in. I would not choose another book club over this one any day. It's absolutely an amazing place to be. It's great community. And the more you participate in HVA-Chicks programs, the better of a technician you are. And that's been proven for 4 years. 4 years, we have companies who will only hire our technicians. We have companies that reach out to us in order to judge, right? Judge technicians and different things that those technicians do. Can you come and judge because you guys are the best of the best of the best? That's not because we're teaching the best material. It's not because we already started with the best techs. It's because we have a community where we can all lean on each other and network. So if you're part of that community, you have not only your own experience, but everyone's experience at your fingertips. All you have to do is ask, and all you have to do is participate so people know who you are, right? So definitely do. Thank you guys for being here. This will be recorded and put up in the coalition. And wash first, so you have measurements after it's washed. Yes, always never take a measurement for, well, no, you should take a measurement for airflow when it's dirty, but you shouldn't take a charge measurement before when it's dirty. I always take an airflow before and an airflow after so that I have something to show my customer. This is how it was when I showed up. This is what I did to fix it, right? You want to always have something like that, but you never want to test your charge with a dirty coil. It will lie to you 100%. Every time. All right, guys, I'm going to go ahead and cut the recording. Thank you for being here. I will see you tomorrow. And we have FM Hero, one of our sponsors, on Misfits of HVAC tonight. So if you are not busy, come on over and watch. And I'll catch you all on the flip side.
Thank you.